Greetings, my name is Hardik Raj, and today we will be discussing the problem XOR with subset. This is a simple problem, and the prerequisites are dynamic programming (DP) and bit manipulation or bits. This problem was asked in December Challenge of 2014. Let's look at the problem description. In the problem, we are given an array of integers a1, a2 up till an, that is n integers. Each of these integers is from 1 to 1000, or in the subtask 1 is from 1 to 20. Okay, and the function fp, where p is a subset of a, is defined as the XOR of all the integers present in the subset. If p is empty, then f of p is equal to 0. Given an integer k, what is the maximum value of k XOR fp over all possible subsets p of a? Okay, now let's look at the problem explanation. In the problem, we are given n integers a1, a2, a3, and so on up to an, such that each of these numbers is from 1 to 1000. Right, let's just check it. Yeah, so each of these numbers are from 1 to 1000, and there are two subtasks. In subtask 1, the number of elements is less than or equal to 20, and in subtask 2, the number of elements is less than or equal to 10 cube. We are also given an integer k which lies between 1 to 1000, and what we are required to do is we need to find all possible subsets. So let's take an example. Let's say n is 3 and we have elements a1, a2, and a3. Then the possible subsets are, excluding the empty one, a1, a2, a3, a1, a2, a2, a3, a1, a3, and a1, a2, a3. In all of these subsets, what we need to do is we need to take the XOR. We need to take the XOR and like this. This is XOR, and finally we need to take XOR of all these subsets with k. Let's use a different color. K, and here again XOR, and we need to find the maximum such value. From these value, we need to find whatever gives us the maximum value. So here f of p is nothing but XOR of all elements of subsequence p, and for all such subsequences we need to find the maximum value of k XOR f of p. Oops, yeah, we need to find k XOR f of p. Let's discuss the brute force solution first. The most brute force would be to generate all the subsets and then do k XOR f of p over all such subsets and find the maximum value of this expression. As for the time complexity, there are 2 power n subsets, including the empty set, or you can say 2 power n minus 1 if you don't want to include the empty set, but since 2 power n is the dominating factor, we can write it as 2 power n. and for all those subsets we need to iterate over the elements to find their XOR. So this is another factor of n. So this is the total time complexity of the brute force solution. Let's look at the code. So yeah, this is the code for the brute force approach. I'm taking input t, which is the number of test cases, and for each test case I'm calling the solve function. In each solve function I am taking n and k, and here this is the array input. This answer, this is basically the maximum possible value of k XOR f of p, where p is a subsequence. Now int m is equal to 1 left shift n. This is basically 2 power n, and it means these are the total number of subsequences possible. Like I said, there's 2 power n subsequences. Okay, and all right, and now int current XOR. Yeah, so this calculates f of p. This calculates, and this is the calculation of f of p, and here this is k XOR f of p, and we update the maximum answer, and finally we output the answer. Now how this works, or actually this thing, it might seem a little bit confusing if you're not accustomed to writing the subsets. So I will just give a gist. Let's say we have 3 elements, or let me just erase this. Let's say we have 3 elements, A1, A2, A3, and we wish to generate all possible subsets. So how many possible subsets are there? We know that there are total 2 power 3 subsets, right? So what I'm going to do is I'm going to say that if I want to take a particular number, then I will represent it as 1, and if I don't want to take a particular number, I will represent it as 0, and say I want to take A3. So what is this value? This is 5, right? Or more clearly, let's say that 0 0 0 means we don't take any element. 0 0 1, we only take A3. So here we have no elements. Here we have only A3. 0 1 0 means we only take A2. 0 1 and 1, and let's add one more column over here. And here I will be writing the decimal representation of this thing. So this is 0. Okay, this is 1. This seems like a binary concept, right? If we try to see this, this is nothing but a binary number. 0 1 0 is the binary representation of 2. 0 1 1 is the binary representation of 3. And here we have our elements A2 and A3. Similarly, let's say that we have 4. So we represent it as 1 0 0, and our element is A1. 5 1 0 1 means A1 A3. 6 is 1 1 0, and this is A1 and A2. And finally 7, this is 1 1 1, this is A1 A2 and A3. So this is what we are doing over here. This outer loop, right, this one over here, it iterates over these numbers. This is from 0, this is from 0 to 2 cube minus 1, and similarly till uh, okay, yeah, and this is 2 square minus 1, right? So yeah, the outer loop basically iterates over this, and now we need to know if the ith bit is set or not to say whether or not we are going to take the ith number, or in this case I'm representing it with j. So here j is 0, actually j is, yeah, this is j is 0, this is 1, this is 2, and this is our j value. Okay, in array it's just the reverse. In array it is supposed to be 0 1 2, but I'm saying that my j value is from here. It's just for easier understanding, and I check if my number I is something like this, then I will check whether or not this number is set. If it is set, take the value corresponding to this j. Then again, since this j is not take, we will not be taking j, or it's actually j plus 1, and then j plus 2. We see that this is set, and so we take the value. This is what we are doing. So this is 0. In binary representation, this number is 2 and this number is 4, right? And this number is actually 1, sorry, this number is 1, this number is 1, this number is 2, and this bit is 4. So we check if the bits are set or not. I am not going to drag this a lot. You should definitely give this a study. So, and this is pretty common, this brute force approach. So yeah, I'm just checking if the bit is set or not, and if it is set, we just take the number from here, and at the end we just output it. Let's try to submit it. Okay, actually I've submitted same code a few moments before only, so it was enough for subtask 1, but in subtask 2 it's giving TLE as well as some wrong answers. This is because it's not calculating properly. What is happening is, in case of n greater than 20, 2 power n becomes greater than 10 to the power 6, and we have a time complexity of 2 power n into n. So this becomes approximately around 10 to the power 7 or 8 maybe, and in some cases it even goes beyond, let's take n as 100. So this will go way beyond 10 to the power 9, and that is the reason for TLE. And in this case it should have given TLE, but it actually gave the worded wrong answer, but that's not an issue at all. Now let's see the optimal approach. Now for the optimal approach, let's take a step back and think, what if we already knew what the possible subset XORs can be, and at the end what we would be doing is we will be just doing k XOR with possible numbers, right? And let's look at what is the maximum value of these possible numbers. So for that we have to look at the constraint. Yeah, here n is less than or equal to 1000. So let's take these particular numbers: 1, 2, 4, 8, 16, 1632, 64, 128, 256, and 512. The decimal representation, let's write the decimal representation of all these numbers. For 1 it's just 1, for 2 it's 10, for 4 it's 100, for 8 it's 100, for 16 it's 1 quadruple 0, for 32 it's 1 pentuplet 0, for 64 it's 1 sextuplet 0, and for 128 it's actually 0, 1, 2, 3, 4, 5, 6, 7. What do we call 7? Well, let's call 1 and 7 zeros. 1, 2, 3, 4, 5, 6, 7. This thing right here is not a 6, it's a 0. Similarly, for 256, we have 1 and all these are 0. And as for 512, 1 and zeros. Okay, some of these zeros might be hidden over here, but that's not an issue. We want to take the XOR. Okay, so the XOR would be 1, 1, 1, 1, 1, 1, 1, 1, 1, and 1. And this is the binary representation of 1023. Base 10 is equal to this thing in base 2. So what we have come to know is the maximum number that we can achieve is 1023. And now that we know the maximum number is 1023, how is that helpful? So we can just run a loop from 0 till 1023 and check if it is possible to form a number I which belongs to this number 1023, and if it is possible to form I, if it is possible to form I such that I belongs in this range, then we just update our answer, that is the global answer, with I XOR k, and we take the maximum of these two, and at the end we will be getting the optimal output. So yeah, we just need to know if the numbers from 0, 1, 2, so on up till 1023, which all of these numbers are possible to make. And if a number is possible to make by taking XOR of some of the numbers present in the initial array, then all we need to do is we need to XOR it with k and update the maximum answer. Okay, now let's look at the approach. We know that it is possible that if we have an empty subsequence, then we can get the number 0, and at the end we can just do k XOR 0 and we will get our answer as k. Okay, so what I'm suggesting is, let's say we have a table of some sort. Okay, just all right, and this table or this array will have some index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it will go on up till 1023. What this table will store is if a number is possible to make using some subsequence and taking the XOR of that subsequence, then the corresponding index value or the value at that index will be 1, otherwise it will be 0. So since it is always possible to make 0 by not taking any element, we can say that let's call it a possible array, whether or not it is possible to make the number I using some elements in the subsequence, and we take the XOR. Okay, and for example, let's say we have our 1, 2, 3. This was given in the question also. So what we want to do is we say we pick a number, and using that number we check what new numbers we can make. So from 1 we try to look at can you make 0, can you make 1, can you make 2, and so on. Can you make 1, 0, 2, 3? But how do we look at that? That is very simple. What we do is we append this A to an already existing subsequence, and that subsequence will have some value, and to that value we will uh, XOR it with 1, and we will get a new value. So for that, for a new value to exist, we know that 1 exists. We know that this quantity exists, so this left hand quantity should also exist, right? And that is what this table will help us for. We will the indexes will be our left element, and A of I will be our current element, and we will check if it is possible to form this left hand side quantity. Then we can form a new right hand side quantity which will be XORing it with A of I, whatever this quantity is. So for example, we have 1. We see that it is possible to form 0. Then 1 XOR 0, or actually left quantity is 0 and right quantity is 1. So it becomes 1. Since it is possible to form 1 and it is possible to form 0, it will be possible to form 1. Okay, and now we look at 1 as our left hand side quantity, and we will XOR it with 1, and this is 0. Since the XOR of two same numbers is 0, and we look that okay, this is possible. The left hand side quantity is possible because of the Boolean array, and this is our right hand side quantity which already exists. So this final new quantity should also exist, so we just make it 1. Since it was already 1, we don't bother with it. Now we have our left hand side quantity as 2 and our right hand side quantity as 1. We look, is it possible to form 2? Right now it's not possible, so the resulting number will also be not possible. So right now 3 is not possible. Similarly, we say that now our left hand side quantity is 3 and our right hand side quantity is 1. The XOR of this 2 is 2, but since it is not possible to form 3, it will not be possible to form 2. We do this for every single element, and at the end we get the updated array. Now let's say we are looking at 2. So our left hand side quantity is 0 and our right hand side quantity now becomes 2. So 0 XOR 2 is 2. Since it is possible to form 0 and 2 already exists, that is, we have it in our hand, so the right hand side will also exist. Okay, now similarly update this with 2 and check 1 XOR 2 is 3. Since the left hand side quantity exists because of the Boolean array and we have a right hand side quantity in our hand, then the new value will also exist. Similarly, we will look at with 3. So 3 XOR 2, it is actually 1, and since both 3 and 2 exist, 1 is also exist. We will look at 4, but since 4 does not exist, the entity arising from this 4 will also not exist. So yeah, that is the approach. Let's look at the code. This is our DB array, and we are taking our input over here, and n and k. Actually, let's go line by line. This is our DB array. This is our integer array. We are doing this one based indexing. Int n and k. N is the number of elements. K is the quantity that we want to XOR something with. So finally, we have this array of what is possible and what is not possible. And at the end, we will do k XOR with the possible candidates. So we will do k XOR with 1, k XOR with 2, k XOR with 0 also, since 0 is possible, and k XOR with 3. And the value of k is 4. So 4 XOR 0 is 4. 4 XOR 1 is 5. 4 XOR 2 is 6. And 4 XOR 3 is 7. Then the maximum value is 7, we output 7. Same thing we are doing over here. After taking the input, we initialize dp of 0 as true, because it is always possible to form a subsequence, that is an empty subsequence, which will have the value 0. Now we handpick our elements from, you can do this in any order, the order does not matter over here. Next, we look over the possible array, that is the dp array. The new value would be, this is our current value j that we are looking at, or the left hand side quantity, and array of I is a right hand side quantity. So this new value will be possible only if the left hand side quantity is possible, and if the left hand side quantity is possible, the new value also becomes possible. And after doing this, we initialize our answer with 0, and we look, after considering all the elements, what are the uh, possible subsequence XORs that we can get, and we just update this. If it is possible to get I as an XOR sequence, then we just update our answer with k XOR I, and at the end we just output our answer. Let's just try to submit this. Okay, so as you can see, this code was submitted. Now let's look at the time complexity. This taking input does not take any time. This takes O of n time. So right now we have O of n for taking the input. Next, this outer loop runs from 1 to n, that is the number of elements, and the inner loop runs from 0 to 1024. And the value of n can be as large as 1000, since it was already given in the question. And so in this case, it runs for an order of n squared. Yeah, this runs n time, and for each of these n times, the inner loop runs n times. So the time complexity is n squared. Since the dominating factor is n squared, so the total time complexity is O of n squared. This is our time complexity. Let's look at the space complexity. We are declaring two 1D arrays of size n and no other space. So our space complexity is O of n. And mind this, that this is per test case, time complexity per test case. So taking into consideration the number of test cases, we get T into n squared. That is the total time complexity, and this is our space complexity. Okay, before ending the video, I just wanted to do a dry run of one more example. So let's say our array is something like 2, 6, and 7. How we are going to generate the TP array or the possible array? So for that, we will need an array of size 1024. Wait a minute, just. Okay, yeah. So it's 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9, and so on up till 1023. This will be our original DP array. And we initialize this 0 with 1 and rest of them with zeros. Okay. Now we pick 2 as our current element and we check what are the possible numbers that we can make. So since 0 is possible, our left hand quantity, our right hand side quantity, and a new val. Okay, our left hand side is right now 1. Our right hand side is 2. Since both of these are possible, our right hand side is 0, left hand side is 0, sorry, it's 0. The right hand side 2. The new val would be the XOR of these two, so it's just 2. So since both of these are possible, 2 becomes possible. Now our left hand side quantity becomes 1. So since 1 is not possible, it makes no sense to look at the new value. Now our left hand side quantity is 2 and the current quantity is 2. The new value is 1. The new value is 0. So since both left hand side quantity is possible and we have right hand side quantity in our hand, so the new value becomes possible, but it was already possible, so we don't bother. Similarly, we look for 3, 4, 5, 6 up till 1, 0, 2, 3. Since none of those are possible, I won't be looking at those, but our code will. Now our current quantity is 6. Okay, yeah. Now our RHS becomes 6. So 0 XOR 6 is 6. So 6 becomes possible. 1 is not possible, so we don't look at that. 2 is possible. So 6 XOR 2. 6 is 1, 0, 1, 1, 0, and 2 is 0, 1, 0. The XOR is 0, 0, 1, and this is 4. So the new value is 4, and since 2 is possible and we have 6 in our hand, so 4 becomes possible. Now 3 is not possible. Now 4, since 4 is possible and 6 is possible, so 4 XOR 6 is 2, so 2 becomes possible. Since it was already possible, we don't bother updating it. And yeah, after 6 we won't be getting any new numbers. We would look at 5, 5 will not be possible. We will look at 6, 6 XOR 6 is 0, 6 which is already possible. Okay, now let's look at 7. So this is our current quantity. This is 7 over here. Okay, so since 0 is possible, we have 7 in hand, so 7 becomes possible. Now since 1 is not possible, don't bother. 2 is possible, so 7 XOR 2 is 101, which is 5. So 5 becomes possible. Here 5. Now since 3 is not possible, we don't bother. 4 is possible. So what is 7 XOR 4? This is 0, 1, 1. So this is 3. So 3 becomes possible. Okay, now 5. 5 XOR 7. What is this? 5 and 7. So it's 0, 1, 0, which is 2. So since 2 is already possible, we don't bother. And 6. Yeah, 7 XOR 6. What is 7 XOR 6? 1, 1, 0. 7 XOR 6 is 1. So even 1 becomes possible. This is because 7 we have 7 in our hand and 6 was possible. Now we look at 7. 7 XOR 7 is 0. So 0 becomes possible. It was already possible, so we don't bother. And the rest of these are not possible. So we can get each of these values from 0 to 7 using the numbers 2, 6, and 7. Well, so I hope you understood this solution. I did a sample dry run to explain the process even further. And I hope to see you next time too. That's it for this one. Like the video if you understood the concept. In case of any doubts or queries, please feel free to drop a comment below. Do try and submit your own solution on CodeChef after watching this tutorial. If you are interested in competitive programming and want to learn and master data structures and algorithms, then CodeChef is a one-place destination for you. Every week we post CodeChef problem explanations, frequently asked interview problems, conceptual videos on various programming topics, and also conduct live problem-solving sessions. To stay notified of our upcoming uploads, subscribe to our channel and hit the bell icon below. See you next time.